We are live. Hi everyone, I'm TigerOcty3. Today I'm going to code Blackjack. It's pretty popular. It's a thing. The way Blackjack works is all players, including the dealer, are initially dealt 2 cards from a standard deck of playing cards. The goal of the game is to make your hand total 21. Or if you have 5 cards. Now the goal specifically is to get this much while not exceeding 21. Numbered cards are worth their labeled value. Face cards are worth 10, and ace can be worth either 1 or 11. Your choice. So, I know we're gonna need this, of course. The deck is going to be a list of ace times 4, because we need 4 of them. The suit doesn't matter. And then we will shuffle it. Makes sense. We have a deck. We're going to shuffle the deck. And then players. Will it be multiplayer? One of them. Let's just make it you versus the computer. Let's do that. Player equals, and this is going to be the hand for the player. Deck.pop for throwaway variable in range 2. List. Let's see, I want to make 2 of these, one for the player, one for the dealer. Is there any tidy way of doing that? This is fine, I guess. CPU equals the same thing. Let's get an infinite loop over here. Let's see. We're gonna have the player go first. So first it's gonna print the player's hand, and I'm gonna unpack it so I don't get commas or brackets. How about... Oh, and the way, I should mention, part of the rules, the way you get cards and attempt to achieve the goal is when it is your turn, you can either ask for another card or not. And it's traditionally you ask for another card by saying hit, and you indicate that you do not want any more cards by saying stay. If you hit and hit or hit me or something, hit me with another card, and you go over 21, you lose, and that is called bust, I think. Yeah, bust. I'm familiar with the phrase dealer bust. Means the dealer took a card when they shouldn't have. Okay. Let's see. We're gonna look at what we have in our hand. And then so this if input, notice I'm not saving it, doing anything with it. It will either be an empty string if the user just hit enter, or a non-empty string if they type something in and then hit enter. I'm just checking whether it's a non-empty string. Enter to stay. I don't know. If they want a card, player.append deck.pop. The pop method for list objects takes an element from the list, removes it from that list, and it's the reference to it, I should say, and returns it. So when I do deck.pop, if you don't give it an argument, it by default removes and gives you the last item of the list, or you can pass it an index like .pop 0 to take out the first element. Popping from the end is a little more efficient because it doesn't have to rearrange stuff as much. So we're going to take something out of the deck, and we're going to append that to the player's hand. Very good. We're going to need values. How much is each of these worth? Value equals, and we're going to make a dictionary. How am I going to do aces? That can be 1 or 11. That's going to be interesting. Let's do the rest for now. 2, 2, 3, 3, 4, and 5, and 6, and 7, and 8 is 8, and 9 is, oh, what's 10? Oh, I forgot 10. There's a 10 number card. Whoops. 0. Whatever. That's fine. I don't actually care. 9. 0 is 10. Let's do the following. Let me just fill these in first. Queen, king, and ace is going to be 1 for now. My plan is that we'll do this first, and then we will go through the player's hand looking for aces and say, would it be good to add 10 for each one? And if any of them are 10, sense. If adding some quantity of 10s produces 21, then they win. They are set. But otherwise, they're just counted as 1. Sure. It's fine. Okay. If some map value.get player is more than 21, print you lose, and then break. Otherwise, so this is what did I just do here? First we're going to map, which means apply a function to each element of an iterable, and we're going to go over the player list of cards, and the function we're going to send each of those elements to is value.get. And so we're going to look in this dictionary, and we're going to attempt to get that that element as the key. And that will produce, if we have, for example, 2 and 3, we will then have the integer 2 and the integer 3. And then we send that to sum, and we'll get 5. Otherwise, this is something that should probably be in a function. But let's do a little more first. If we don't lose for card in player, this is going to have to be a function because I want to check the same thing for the CPU. If card, let's do this. Total equals this. We're going to need to put total in there. Card is an ace. We add 10 to the total. And if total is now equal to 21, print you win and break. This is probably something that I could reduce the number of lines or the level of indentation. I don't know. This is pretty straightforward, I think. Let's write a function. What is it going to be? Who is playing and their hand? How about? Okay. All right. This is going to be the hand. And this is going to be someone. Format who. Someone loses. For card in the hand. and this needs to be someone wins. Who wins? Who loses? Going through the hand, etc. This will be something else because we're not in a loop, as you can see. It's going to be what do I want my boolean to be? I'm going to be checking if and then this function. If we're done, then break. Return true. Otherwise, we will return none by default. Okay. All right. If check player and the player's hand. Break. Fantastic. Now how about the computer? What's the AI going to do? Let's see. Computer. We should check first. No? Everyone gets cards, because you could get like a 10 and an ace, and then you win. So we should check for wins before getting a card. We can do it multiple times. That's okay. If this one wouldn't break, if check CPU and CPU also break. I have these separate. Should I have them separate? If the player, you can't instantaneously lose when you're dealt cards, because the highest cards you can get are aces, and those can also be low cards. You are dealt 2, so the highest you can get here is a 10. You can get 20, or you can get an ace and something else, and then you can say, well, that's 1 instead of 11. Let's do the following. If the player has won or lost, or the CPU has won or lost, then we will stop the loop. If the player wants a card, they get one. Then we will check again. Okay. Actually, This seems bad, doing it multiple times. Let's take that out of here for now. In an actual game of blackjack, you would get cards. Then you have to check if you win, and then you get a card and check if you win or lose. This would be... and it has to be immediate. Actually, this is fine. Let's do this. Let's put this here. If this for the CPU is, let's say if it's less than 15, they'll want a card. You're not going to count cards and do all that fancy stuff. It's not happening. If they have less than 15, they're going to try for another card. I guess maybe if they have an ace, that could they could say, okay, now I have 20. If they get a 9 and an ace, that would be 20, and they probably don't want another one. But it could also be less than 15, so that's fine. Okay, let's do that. Simple AI. CPU dot append deck dot pop. Is that it? That can't be it. Let's actually change these to false. Refactoring. All right. Okay. So we're going to check if the player has won yet. And has won or lost. So that's the first thing we'll do. And we're going to look at their hand and say if the total is more than 21, that's not going to happen, return false. Or if they won, we're going to print they won and return false. This has to be and now, because if the player had won or lost, it would then check the computer. So we're not doing that. While this is still going and that's still going, so if this returns, I gotta add something here, return true. So if they haven't won or lost, this will be true. Okay, and then we'll check this one. And if they're both true, then we will tell the player their hand. How about, if I was using Python 3.5, I could do this as well. But you can't do that in 3.4. It won't let you. How about, that's fine, I think. So we'll print your hand. If, actually we do need to print, I think everyone's hand is it public? I don't know. No, I think it is private. Except for the dealer? I don't know. And I don't care. That's a trivial thing. It's either print or don't print. So I really don't care. So if no one has won yet, print your hand, and you can enter something or nothing, and the computer will maybe choose to get something, and they can maybe add something to their hand if they want. So if you start with like 20 and you keep staying, you say I don't want any more. Oh, I forgot the number of cards. If len of hand is more than 4, print such and such wins. Format who. Okay. Let's do the following. Let's also print the hand over here, everywhere. And I can do, I can do this, I believe. Yes, I can do that. Blah blah blah. I just can't do 2 of those. I believe, yeah, doesn't like that. I couldn't do. You can't do this in 3.4. Syntax error. They eventually realized, why is that a syntax error? And now you can do it. If the total is more than 21, then you lose, and we're done. Actually, haha. Here's a funny little trick I'm gonna do that I would not recommend, because some people write this sort of statement not realizing what it does, and then their code doesn't work. They can't figure it out. You know what I'm gonna do? This. Because print returns none. Actually, do I need that at all? No, I do not. If there's no return, it'll return none already. Why was I saying we had to return none? Don't have to do that. So, this is how you lose, and this is how you win with an exact number, and this is how you win with lots of cards in your hand, and all of those will end up returning none. Now I need, won't necessarily be, it just returns true at the end, so no. Should I put those returns back in? Should I just put them back in? I think I'm going to put them back in. So I would have to put it in a bunch of else's, etc. So this will just end the function right there, because I would have to do if total is more than 21, else this, or if that, and whatever, and all of those would need, and then I would need else at the end. If, elif, and then else return true. So no, I'm gonna save some lines. Is that it? Maybe? Let's run this and see what happens. Blackjack. How are we? Half an hour, okay. Let me turn on this dealie. Blackjack. I have an 8 and a queen. I'm gonna stay. I don't know what the computer did. Possibly something. Oh. The computer is staying as well. I'll tell you what. That's a bug. Let's get cards. I lost because I had too many, of course. So the bug in this is that it keeps going. If you stay, it waits for the other person to stay. It's not. It doesn't say everyone is satisfied with their hand. So we're done. Let's see. We'll need some way of saving. Here we are. If I'll want to save this input. Darn. If I and I can just get this again, but that would be kind of bad. It should actually be P for player. Single character variable names are bad, don't use them. And now I will use them. Only for professionals. If not P and not this thing, break. This actually doesn't look very good, does it? It's going to be more than one screen. Oh well. AI equals this. If AI, do that. If not P and not AI, break. No, not yet. If player is more than the, oh no, I have to add those up. is I have to check the aces again. Because if a player is relying on an 11 to get a higher score than the CPU, then they win with that. Maybe I should return the possible scores. This is a direct loss, direct win, direct win. Instead of true, let's do something else. Do I need to save a different total? That's annoying. Let's do that. Let's call this a subtotal. Total gets the subtotal, and then we do that. Actually, total.append the last one plus 10. And these are going to be the possible hands, possible scores this person can have. Okay. Okay, if the subtotal is more than 21, just say you lose. Otherwise, we say we have a list. Oh, no. We want okay, if they didn't lose, then we're going to make this. Okay, yes, I do have return. I was afraid of having a return total when we only make the total in here, but there's a return. So we don't actually need that, matter of fact. If the subtotal is less than 21, or more than 21, sorry, we say return none. You lose. Then otherwise we check if they have more than 4 cards. And then if they do, we just say you win. Otherwise, we make a list for the total, go through all the cards, let's actually do this. Hang on. Trying to make this a little tidier. Plus list range of subtotal subtotal plus 10 times hand dot count A plus 1 and 10. Is that it? Is that good? Let me get rid of this thing for you. And then we don't need... And then this would be if 21 in total. We do that. Otherwise, we return the total. Okay. What in the world did I do over here? I have a list over here with one item. That's the subtotal. That's the base value that they can have with no aces and stuff. And then I make a list out of a range object. And that range object starts at subtotal plus 10, actually. So if they have an ace and a 3, 2 aces and a 3, let's say, that would be 5 for the subtotal. And so they have 5, and then when you add 2 lists together, you get a new list object. It's like concatenating strings, pretty much. So we'd have 5 over here, and then 15, and we want to go to 26, and then go every 10, because we do want to include the 25. So we have 5 over here, and then 15, and if there are 2 of them, we've counted the number of A's, and there are 2. 5 plus 20, because 2 times 10, 20, plus 5 is 25, plus 1 is 26. So 15 to 26, and we're going every 10. That gets 15 and 25. So we have 5, 15, 25. Great. All right. Let's say item for item in this. If item is less than or equal to 21. Okay. All right. Actually, more than 21? Yes, equal. Okay, so this is a little comprehension that filters out the ones that are over 21. We can just say in. I was going to do if total minus 1 with the equal, but you know, it has to be backwards. If the last thing in total is 21, then they win. In is fine. Otherwise, we return the list of possible things they can have, which for our hand of 3 ace ace would be 5, 15, and 25. That would just be 5 and 15 because we filtered that out. If the last, if the highest possible player's hand, including aces, is this would be a lot simpler without aces, but that's okay. Is more than AIs, player wins, or if it's less, print CPU wins. Oops, I forgot to terminate that string literal. Else, I want to print both of them. I want to unpack two lists into this. I've been planning on getting Python 3.6 when it's officially released in December of this year. So that's pretty close. It's like a couple months away. Print tie, and then we will print the player and the player's hand. Actually, that is those are printed. Oh, only if they lose or win. Yeah. CPU and CPU. Okay. Get P. If P do that, get the AI. If AI do that. Significantly longer than one screen. Look at that. 39 and we only for 31. 8 lines longer. Well. Okay. What have we got? We have got a missing parenthesis. Haven't we? There we go. Had quotes in the wrong places. All right. I feel like I just broke everything. Let's see what happens. I have an ace and a 2. That's either 3 or 13. So I'm going to get one more card. And now I have 12, 13, or 23. Let's get one more. Oh, goodness. I got 21. So that's great. Let's try again. Ace and a 7. Let's get some more cards. 17, 18. I'm gonna stay. Something's wrong here. This has to save the, whoa, the totals don't go anywhere. Return total and it goes to here. Whoops. Oops. My bad. I'm already using this value, that value. If not this and this, this is what's wrong. It has to be these things. See, if I just call this, they could both win at the same time. Like it would print out that the player wins, and then it would print that the CPU wins. I really don't know. Player and CPU. I don't know. My variable names are not very good today. PL and CP. PL CP. If not, if the player is done going or the CPU is done going, we break. And that will already have printed something. Okay. It grows. Let's see what happens now. CPU wins with an ace and a jack. Wow. That's fair. OP, nerf. I lost instantly. Okay. Sometimes that happens. 9 and 7. Let's stay. Ooh, CPU loses. Oh, it got a king as well. Probably had a king and a 3, and it's like, I have 13, I'm fine. Then it gets another 10. That's bad. And then it has 23. Let's try that again. Queen and an 8. Let's stay there. CPU loses. Oh, it got a 10. That's poor luck for it. I want aces. King and a 4. Let's get a thing. That's 20 right there. Let's stay. Player wins. Oh, I see. So this is what happens when both of us stay. Aha, very good. At least I got that. I don't know about the aces, but we did not have any aces. That's fine. So I had 20, and the computer had 18. And then it printed king, 4, and 6. Oh, I need if all this. A break, because it'll just keep doing that forever. I forgot to break. Hey. So, if the game conditions are someone lost or won, a hard win or lose, let's say, then we're done. Otherwise, we're gonna show us the hand and get input. If we want something, we get it. If they want something, they get it. If no one went, if everyone is staying by now, then we check which one won. And we print the hands, and then we break. Okay. This is, I have to pick something and lose. Okay. 3 and a king. Let's get something. I don't know. 19. Let's stay there. And that means the computer stayed as well. And I had 19 and the computer had 17. Okay. 7. Let's get a thing. 13. Ooh, an ace. That's 14. 1. Oh, I lost. Okay. Oh, we got a 10. Yeah, that's bad. A jack and a king. I don't know. Maybe I should not sort the deck so I can get things and see what happens. That's an idea. I mean, not randomize, not shuffle it. Because honestly, I want to test my function. 18, whatever. Oh, the CPU wins. It had 20. Okay. So that's 16. I lose. I want an ace. That's 18. It's not going to help. Oh, a tie. Both at 18. So that works. 15. Nope. I want an ace. There we go. That's not really... The 10 value of that will not be used. 15, let's get one more. I lost. That's fine. I busted. 14, 17, I don't know, I don't care. I want more aces. Oh, the CPU got 21. A jack is 10, and then 18, 19, 20, 21. That's good for it. Can I get some aces up in here? Oh. I had 18, and then I stayed, and the CPU got up to 19. It's pretty good. Unbeatable CPU. No. This is 14. Let's get something. 15, 16. I want an ace where it can be the difference between winning and losing. Let's stack the deck. So I want each of us to get, let's say, 2 aces, and then how would that work? How about 5 and 5 and ace somewhere? So the player will have... Here's what we're gonna do. I want to get a 5 and 5 for me, and then like about a jack and jack for the computer, and it will not do anything. And then I will get an ace, and I don't know, another ace, doesn't matter. Let's fill this with, not with that. Okay. So player is populated first, and that'll pop 5, and then it'll pop 5, and then it'll get the CPU. It'll pop a jack, and then I will say hit, and I'll get an ace, and then I will stay. So let's try that. Oops. 5 and 5. Let's get something. Player wins. 5, 5, and ace. So I got 21, and it noticed. That's great. What happens if I get multiple aces? What if it gets a 9 and a jack? So that's 19. And I get a 4 and a 5, so I would have 20. I want to hit me once. And I think that's good, because I can either have 4 and 5 is 9 and then 10, or I can add 10 and have 20. And player wins, because I had 20. There we go. Take out that, take out that. I think that's it. Okay. 43 lines. It's longer than I wanted, but this stuff of what if everyone stays, you don't want to keep waiting for the other person. And the whole deal with aces, kind of funny like. But I think we got it. I'm not super proud of this, but I really wanted it nice and short. Short, simple words, like total and how about lunch. That's from a Winnie the Pooh Bear cartoon, where Pooh is outside Rabbit's house wanting lunch, and he shouts at the door, "Is anybody home?" And Rabbit says, because he's totally home, "No." Oh, bother, right? And you sound like Rabbit. And then Rabbit's like, "Oh no," and he gets like an empty honey pot and he disguises his voice. Is that Rabbit's voice? It isn't meant to be. It's not supposed to be Rabbit's voice, because I'm pretending. He's like, Pooh's like, "Oh, I see. Okay." And then he says, he likes Rabbit, because Rabbit uses short, simple words, like, "How about lunch?" and "Help yourself, Pooh." And then eventually he, gets in. I don't remember how. What was it? I think he, like, opens the front door and sees Rabbit, and Rabbit's like talking into this empty honey pot, disguising his voice, and it's like, "Hi." And then Rabbit knows that all is lost, and he says, "How about lunch? Help yourself, Pooh." So, yeah. I wanted short, simple words, and so I came up with this nonsense. I'm not proud of that, but that's okay. Actually, I could do... Let's see, maybe I can improve it. For item in... this with what's it? Okay, interesting. And then I don't need that. Alright. So I have... that's probably just too long. I gotta do that. So we have this subtotal, and then because the subtotal is guaranteed to be less than or equal to 21. And then for the rest, we go through each item in this range object and only include it if it's less than or equal to 21. Okay. If they did get 21, return print with the whatever and the thing. Okay. Player, CPU. Seems fine. Let's make sure. Jack and a 10. Let's stay with that. I win because the computer had a 2 and a 5. And then it got an 8. And then it's like, that's enough. 15. That's good. And I had 20. Let's actually see if we can mess with this. I already get this stuff, CP. So I don't need to do that, because I'm saving it. If the last one of CP is less than 15, then get a new one. Okay. I win. Let's stay a bunch. Oh, the CPU wins. They had 18. That's pretty good, and I had 16. Okay, because what I wanted was, I mean, that should work fine. Because I want to test aces. Really? There we go. They have 21. Okay then. Good for them. So this means the computer will be treating aces like ones, mostly. Actually, this eliminates the ones that are too large. So it will treat, if there are aces in the computer's hand, the computer will, the results for that hand will have every possible result except for ones that are over 21, and the computer will consider that to be the highest one. So if it has a 10 and 2 aces, if it has a 10 and a 5 and 2 aces, so that's at a minimum 17. Let's actually, can we do an intermediate thing where one of them is okay and the other is not? Let's say it has an 8 and 2 aces. 8 and 2 aces is at least 10, and it could also be 20 or 30. The 30 will be discarded because of this, so it'll see it as 10 or 20, and 20 is not less than 15, so it'll say, I think that's enough, and it will stick with 20. That seems good. I'm happy with that. That's probably good, and I win. So I think this is Blackjack. I think that's it. Stream done. CPU had a 7 and a 4, so that's 11. And it said, okay, one more. Now I'm at 13. And then it got all the way to 22. Unlucky. If it had gotten an 8, it would have beaten me quite handily. I am now addicted to gambling. 9, 13. I lost. I got a king. That's 23. Oh, that was fast. Okay. I'm really good at this game. See? Won really fast. Anyway, that is Blackjack. Tomorrow will be a gaming stream of some kind, I'm not sure. And I think the day after tomorrow, probably Simon. I'm sure you're familiar with it. It's you get a series of stimuli from the computer generated something, and then you must remember them and repeat them. Like red, blue, and then you enter red, blue, and then it says red, blue, green, and you enter red, blue, green, red, blue, green, red, and you enter red, blue, green, red, and then it says red, blue, green, red, red, and you do red, blue, green, red, blue, and you lose. That sort of thing. So that'll probably be the next Python stream. That's my plan. And I think that turned out pretty well. So thanks for watching. Remember to like, comment, subscribe, and I will see you next time. Have a good one.